So we're jumping into geometry now. So we'll be looking at different shapes. We'll study area, we'll look at volume, and today we're going to be starting with angles. So angles show up in all shapes. So we want to go over some specific types of angles and also some pairs of angles, so some relationships between two angles that are important. What do we know about them? Not just their name, but how many degrees they represent. And then how can we locate these in a picture? How can we fill in missing degree measurements based on just what we see? So even without anything given to us, we can look at a picture and figure out the degrees for these angles. Okay, so we're going to start off with an acute angle. An acute angle you've studied before. This is an angle that's small, acute. So this is less than 90 degrees. Now if you look up, I think most of you know that angle 5 here, this represents 90 degrees. And this is your right angle. So this is a 90 degree angle. This is a right angle. Now, we know that's 90 degrees, but do we really understand why? If I asked a lot of you how many degrees is in a circle, all the way around a circle, some of you would tell me the right answer. It's 360 degrees. If you're snowboarding or skateboarding or any of those types of sports, or even playing basketball, and you do a dunk where you do a full spin around, a full circle, that's called a 360. Halfway around is a 180, and that's half of 360. If I cut this in half, I've got a 180 going around here, and then I've got another 180 going around here. And altogether that's 360. So what's going on here with 90 is you're actually cutting this 180 into another piece. You're cutting 180 in half, and you've got 90 and 90. So where you see this angle meet, okay, we're trying to figure out basically what amount of a circle does this angle take up. Because if I continued this circle around that center, it takes up all of this. If I had two of them, it would take up half of it, and that'd be 180. And all the way around is 360. So this piece right here is 90 degrees. So an angle basically is, we talk about them in degrees, and it's how much of a circle is it actually taking up. So an acute angle is even less than this. So we think of them as really small. If we look at angle 6 and angle 7, they're cut up from a 90. So each one of them has to be less than 90 because together they make 90 degrees. And we'll talk about, they have a special name. But each one of these are acute. So if we were going to draw an acute angle, think about what a 90 looks like, and you want to draw an angle that takes up less space than a 90, and we say that it's closed. So 90 would be straight up and down and straight side to side. Acute is closed. So for instance, 35 degrees. It could be anything less than 90. A 90 degree angle, straight up, straight over. We often represent them with a box, and we automatically know that this is 90 degrees. Obtuse angle, so we've got acute less than 90, right is 90, and obtuse is an angle greater than 90. But it's not just that, it has to be less than 180. There are angles that are more than 180 degrees. Okay, so 180 would be completely wide open straight. We can have an angle that goes more than 180, and we're not going to get into those right now. You'll study those in geometry. Okay, but that is possible. So obtuse is not just more than 90. It's kind of in that middle range between, so here's 90. Take a little bit more. Okay, but not all the way to 180. So if we were going to draw it, 90 would be straight up and down. 180 would be a straight line, basically. So something in between that is obtuse. So between 90 and 180, so for instance, 130 degrees. This space in here. Alright, so now we're going to talk about different pairs of angles. So when I take two angles and I put them together and something special happens, they have certain names. So complementary angles are like these right here. So 6 and 7 together are complementary. And what that means is the two of them together, both acute angles, add up to 90 degrees, because this big angle, just like angle 5, is 90 degrees, and we've just cut it into two pieces, the 6 and the 7 angles. Okay, and they add up to 90 degrees if I put them together. So these are two angles with a sum, or add up to 90 degrees. So what this often looks like is you have a 90-degree angle, like this. Now that's not complementary because it's one. Complementary angles means there's two. So this is one angle, and if I cut it into two pieces, you can cut it perfectly down the middle. Then it'd be 45 and 45, because you'd split 90 in half. It doesn't have to be perfect. And I don't even need the degree measurements here. I don't need to know that it's 45, 45, or 30 and 60, or 40 and 50, or any of that. I don't have to know, because if this whole thing's 90, I know that regardless of what the actual measurements are on these two angles, the degree measurements, they're going to add up to 90, because they're inside of this right angle. Now, it is possible to have complementary angles that aren't connected. So you could have an angle here, and you could have another angle here, not touching each other. And if this one's 40 degrees and this one's 50 degrees, then these are complementary because they add up to 90. So the only stipulation is they add up to 90. They don't have to be connected, but they can be. All right, that's complementary. And if you look at the next one, supplementary, sounds very similar. This is also talking about two angles, but they're going to add up to a different number. So complementary is 90. When I go to memorize these, C comes first in the alphabet, and it's 90. S comes later in the alphabet, so this is the bigger number. The special numbers when we talk about angles are 90, 180, and 360. Those are the big numbers. So 360 is a full circle. We're not going all the way there. Supplementary angles, they add up to 180 degrees. So it could be two random angles. So we could have one like this. Now you can't draw another acute angle because they're not going to get all the way to 180. Just remember 180, if you go back to your circle, is halfway around. So they basically, together, if you put them together like a puzzle piece, they'd form a straight line. So we've got this piece in here. It's got to go halfway around the circle. So it's got to fill in this other piece here to get us halfway through the circle. So it's going to have to be a bigger angle like this. This space in here, if you connected it with this space, would be half of a circle. So let's put some degree measurements. Let's say this is 30 and this is 150 degrees. Together, those add up to 180. Now these can be connected, and if they were connected, they're going to form a straight line. So this angle right here is 180 degrees because it's half of a circle. The other half of the circle is on the other side, and it's also 180 degrees, 360 altogether. But this is not considered supplementary because this is just one angle. Okay, it's called a straight angle. But if we split it now into two angles, these two angles are supplementary. And I don't even have to know exactly what they are. 30 and 150, or 20 and 160. It doesn't matter. I don't have to see that in the picture to know that they're supplementary, because together here they're forming a straight line. So I automatically know that they're going to add up to 180. They're supplementary. Don't need any numbers in the picture to know that. Okay, vertical angles. These are special ones that are formed, and let's actually look at the picture first. When two lines cross each other, vertical angles are formed. Okay, so what happens is I've got four angles. All together they're going to add up to 360, because if this is the center of my circle, okay, I get all the way around 360. Opposite angles are actually going to be equal to each other. And if you think about it, if you took this and folded it over this dotted line, folded it right over, this angle right here would fold perfectly on top of this angle right here. It's like a mirror image. And you could do the same thing up here and over here. So let's say we knew that this was 100 degrees right here. Without ever seeing it in the picture, another number, I automatically know this is also 100 degrees. They're the same. And so if I knew this angle, then I know this one. Now, since this is 360, I know altogether it's 360 if it's a full circle. Take the 100 and the 100 off of that. Okay, you're left with 160. And these two have to be equal to each other. So these have to be 80 because they have to be equal, and all of this has to add up to 360. So these angles, we'll call them opposite angles. And they're formed when two lines intersect. And we said they're mirror images. The most important part is they are equal. Okay, the opposite angles across from each other when two lines intersect, we call them vertical angles, and they're equal to each other. Very important. And also now linear pairs. Now these are specific to supplementary angles. We actually already talked about these, but they have a special name. These are supplementary angles that actually form a line. So we're talking about this right here. That's a linear pair. They're two angles that when you combine them form a straight line. So I've got two angles. I've got this one and I've got this one, but the bottom of them is forming a straight line. When I put them together like a puzzle piece, they form a straight line. That's a linear pair. So these angles up here that are separated, they're supplementary because they add up to 180, but they're not a linear pair because they're not physically together forming a line. These are supplementary, they add up to 180, but an even more specific name is a linear pair. And when you see linear, it's a line. So it's a pair of angles that form a straight line. So they're always 180 degrees, but they're physically forming a straight line. So the next video we're going to take a look at some problems where we can look at angles and classify them, come up with the names just based on the picture, and then also fill in some missing angles based on what we know.